Alright, so what we're going to do today is we are going to go back and look at a couple of examples from 7.2, and then we're going to finish the rest of 7.2 and cover 7.3. Okay, so Tuesday, Thursday, we've already worked these examples, but for the sake of my Monday, Wednesday class, we're going to recap on that, okay, to make sure that they understand that. So as a reminder, in 7.1, we covered law of sines, right? Okay, so we are solving oblique triangles. And we know that an oblique triangle is a triangle that is not a, what kind of triangle? A right triangle, okay? So we know that our oblique triangles are triangles that are not right. And so when we solved those right triangles before, then we used our, just our trig functions, okay? But we can't do that now that we have oblique triangles. So we're using our law of sines and we're using our law of cosines, okay, which we're going to learn in just a few minutes. So when we did 7.1, what we did discuss is the fact that there are different cases. And so we talked about those different cases, and we said that as we go through section 7.1, 7.2, and 7.3, then we'll talk about each of those cases. So in 7.1 we covered case 1, and in 7.2 we're going to talk about case 2, okay? And so I told you in 7.1 that what you needed to pay attention to was side-side angle, right? Okay, that's when you knew you were going to have a special case, and that you needed to kind of be on the lookout for something special happening, okay? But that you would still start solving that the same way as you would any other oblique triangle, but you just know that if it's side-side angle, you need to be paying attention to the fact that it is going to be a special case. So I've already worked this out because we worked this last class, but to help out our Monday, Wednesday, let's go back and let's recap on this problem, okay? So what happened is we were given angle B, and we were given little b, and we were given little a, okay? So we set that up as using our law of sines, and remember I told you that depending on what you're solving for is what is going to go on top. Remember us discussing that? So in 7.1 we solved for the side, so we put the side on top. But in example 1 of this section, we need an angle measure, so we're going to start there, okay? So I did, remember also we want corresponding, so like I want a little b and a big B, or a little a and a big A, to be able to use my law of sines. So they give me big B, and they give me little b, and they give me little a, which means I'm ready to solve for big A, right? Okay, so that's what we see here. So I set this up as sine B over little b equals sine A over little a, and I put my angles on top again because I'm solving for an angle measure. Is everybody with me on that? Okay, so then I plugged in the information that I was given, cross multiplied, which was the exact same thing that we did in 7.1. That's not any different, okay? But if we're solving for an angle measure, then how do we have to put that in our calculator? Using what? The inverse function, okay? So that's what we did here, was we put this in our calculator using the inverse function, and we were taking sine inverse of 2.3184378991. And when we did that, what happened? We got a domain error, right? Okay, which makes sense because we know that the domain of this should be between what? -1 and 1, okay? So that's not a big shocker, but in case you know, it kind of throws you when you put it in and you get that domain error, it is because of that your domain should be between -1 and 1. So because we get that domain error and we can't solve for that angle measure, then we know we have, that triangle doesn't exist, right? Okay, it's not possible for that to happen, okay? So the answer to this simply is the triangle does not exist, okay? So again, with that side-side angle, we have some special scenarios that happen, or can happen. And one of those is that your triangle doesn't even exist, that there's no solution, so to speak, to that, okay? So that was our first example of case 2 with a side-side angle. Alright, so what questions do we have about that? Is everybody good? I know we're recapping for you, but hopefully that's CJ, Haley, y'all had time to get that? You good? Okay. All right. So let's look at example 2. All right, now there's a lot of writing on here Monday, Wednesday, so I'll just kind of move my paper around, okay, because again, we worked this last class. So we are going to start here and work our way down and then come back over here. So I'll move the paper over in just a second. So again, we were given big A and little a, so that corresponds, right? Okay, so that was good. And then we have little b, which means we're going to be solving for big B first. Now we're still solving for everything that we're missing, okay? But again, this is also a side-side angle, okay? Which means that this also has the potential to be a special case, so to speak, okay? And so we're going to talk about that. So we set this up, plug in what you know, and so we have sine of 55.3 over 22.8, and then sine of big B over 24.9, okay? Cross multiply. And again, we're solving for an angle measure, so how do we type this in? Using the inverse, okay? So we wrote all that out there, sine inverse of your answer. You can do that, and you do not have to type all of that out twice, okay? You can just simply do second answer on your calculator. All right, now this is where you know that you are going to have to test, because if it's a side-side angle, the possibility of no triangle exists. The possibility of 2 triangles exists, okay? So on the first example, the triangle didn't exist. We stop, we move on with our life, okay? But in this one, because it's side-side angle, I know that I have the potential of having 2 triangles that are solutions. So that means that once I find this first angle measure, which we got to be 63.9, I've got to test it and see, is it possible for me to have another one, okay? And so that's what we're doing here. So these are the steps to test that. First of all, take your angle measure. We're going to call that B1 because there's a possibility that we're going to have a B2, okay? And you're going to say 180 minus your B1, and that's going to give you your angle measure for B2, okay? But you've got to check and see, is it possible for that B2 to really exist? So you got to find it first. It's kind of a little backwards. You got to find it first, and then you have to test to see, okay, can it really work? So then you take your 116.1, which you just found, add that to your 55.3 that was in the original, and we get 171.4, and that is less than 180. Okay, why are we checking that? Right, because we need to see if there's a possibility for C, and we know that all triangles, right and oblique, their angles add to be 180, right? Okay, so if I added these right here, my B2, and then this angle from the original, and this was larger than 180, then we would say it's not possible for there to be 2 triangles. Is everybody with me on that? Okay. All right, but since we added 116.1 plus 55.3 and got 171.4, and that's less than 180, that checks, and we know that we have 2 triangles, okay? So we have a B1 and we have a B2. So now that means we're going to finish solving it the same way we've been solving it, but we're going to have two triangles, right? So everything that we find, we're going to find twice, right? So we were given big A in the problem. We just found big B for triangle 1 and for triangle 2. And so now we need to find big C for triangle 1 and for triangle 2. All right, and so that's what you see down here at the bottom. Okay, you're going to say 180 minus the 55.3 that was in the original, minus your 63.9, which was your B1, and that gives us 60.8, which is going to be your C1. Then you're going to do the same thing again. 180 minus 55.3 minus 116.1, which was your B2, and then you get 8.6, so that is your C2. So now we have found big C1 and big C2. Is everybody with me? So based on what was given in the problem and what we found so far, the only thing left to find is little c1 and little c2. Yes, no. So, oh. All right. All right. So let's move this over. All right. And again, you're setting it up the same way we've been setting it up, okay? So this time we need to solve for little c1 and little c2. And again, what was given to us in the original was big A and little a. So you're going to say little a over sine of big A, little c1 over sine of big C1. So make sure you're using your correct big C for this triangle. Alright, plug everything in, cross multiply. This is the exact same thing that we did in 7-1. That's not any different. Plug and chug, put that in your calculator, and little c1 is 24.2. And we rounded that to 3 significant digits because the side that was given in the original was also had 3 significant digits, right? Okay. Alright, then we did the same thing again, okay? But this time we're looking for little c2, right? So your little a and your big A are still the same for both triangles. So we have little a over sine of big A, little c2 over sine of big C2. Plug and chug all of that. Cross multiply and then put that in your calculator and you should be getting 4.15. You should be getting 4.15. Alright, I know some of you are writing this down for the first time, so are we good? Are we getting that? Alright, what questions do we have on that? Because Tuesday, Thursday, I know that this is the second time you've heard that spiel. Okay, but hopefully that helped because this is kind of one of the more confusing problems. So if you're hearing this for the first time today, what questions do we have? Does that make sense?
Why do you have to have a big A and a
Because that's the same for both triangles. Okay, so the question was, if you couldn't hear Peyton on the video, is why do we not have to have another big A and little a? Because that information that they give you in the original is true for both triangles. So the only thing that's going to be different in those triangles is the other information that you find. Yeah. So that's why it's a special case, because you have it's possible for you to have two triangles that have that same big A, little a, and little b, but all the other information is different. Yeah, good question. All right, questions on this? All right. So let's move this up and fill in these blanks, okay, and move on with section 7-2. All right, so as always, we have some fill in the blanks. It's going to be a lot of really things we've already talked about, but just kind of to remind you. So it says, again, notice that it says number of triangles satisfying the ambiguous case, side-side angle, okay? So we've already said that those two cases we just had are only going to happen when it's a side-side angle, okay? So that's when your radar kind of goes up, okay? And you make sure that you're paying attention to that. So let sides A and B and angle A be given in triangle ABC. The law of sines can be used to calculate the value of sine big B. If applying the law of sines results in an equation having sine of B greater than 1, then what happened in that first example we worked? Talk to me. The triangle didn't exist, okay? So then no triangle satisfies the given conditions, okay? That's what happened in our example 1. If sine B equals 1, then one triangle satisfies the given conditions, and B equals 90. Okay? So again, with side-side angle, it's possible for you to have no solution, one solution, two solutions, okay? We didn't work one with only one solution, but it's telling you right here that that's the only time that that's going to happen, okay? So if sine of B is between 0 and 1, then either 1 or 2 triangles satisfy the given conditions. If sine of B equals K, then let B of big B 1 equals sine inverse K, and use B1 for B in the first triangle, and then let B2 equal 180 minus big B1, which is what we did a while ago. Okay, so, I mean, we're writing all this down. It's in words. It may sound kind of confusing, but it's exactly what we just did in that example, okay? We found our big B1 like we always do. Then we said, okay, 180 minus that gives me my B2. Now check it. Is it possible? Say your B2 plus the angle given in the original, is that less than 180? Sweet. We have two solutions. Move on. Okay, or it's greater than 180, we don't have two solutions, only solve for one. Okay, then a second triangle exists. In this case, use B2 for B in the second triangle. Again, that's the same thing that we just said. Alright, questions on that? Alright, let's look at example 3. Alright, so again, I don't want you to stress over the fact of, okay, what is this going to have? One solution, no solution, two. The main thing I want you to pay attention to, is it a side-side angle? Okay, you with me? Alright, and then you know that it's possible, that you know to check it. Okay, but you're going to start out the original problem like you would any other time. Okay, so we're given big A, we're given little a, and we're given little c. So what do you know that we need to solve for first? Big C. Okay, so, and we're solving for an angle measure, so how are we going to write this? With our angles on top. Very good. Alright, so we have sine of big A over little a equals sine of big C over little c. Now plug in the information that you're given. So we have sine of 43.5 over 10.7 equals sine of big C over 7.2. Alright, then what are you going to do at that point? Cross multiply. So you get 7.2 sine of 43.5 over 10.7 equals sine of big C. You're going to put all of that in your calculator, and then what are you going to do? Inverse. This is the first time we've used our calculator. Well, some of us, if you were just looking on. So make sure you double check your mode, right? Alright, and so when I put this in, I do mine by pieces, and so I did the top 7.2 sine of 43.5, hit enter, divided by 10.7, hit enter, and then I did second sine, second answer, and got 27.59, blah, 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 right? Okay, so we're going to round that to how many significant digits? 3. Okay, so that's going to be 27.6. Alright, so there's big C. Possibly big C1 because we know that this is a side-side angle, so we know that we're going to have to check it, right? Okay, so then how do we check this? First of all, we find our C2 if that's possible, right? So we say 180 minus 27.6. When you say 180 minus 27.6, then what do you get? 152.4. And so if we have a C2, this is it, right? But we have to check and see if that's possible. So we take the 152.4, add it to the angle given in the original, so we say 152.4 plus 43.5, and what does that give us? 195.9. We have one triangle or two? One, because this is larger than 180, okay? So we only have one triangle. And then from that point forward, you just solve it like you always would, but in like in example 2 where you had to do it twice for everything, you're just doing it like normal, okay? You're just going to keep solving it the way you typically would. So that means that we have big A given in the original. We just found big C, so what's the next easiest thing to find? B, okay, because we can say 180 minus 27.6 minus 43.5 given in the original. And when you put that in your calculator, what do you get? 108.9, and so there is your big B. So now we have all three angles. In the original, we were given little a and little c, so the only other side we need to find is little b. So what are we going to use to do that? Our law of sines, right? Okay, we know that we're going to use little a and big A because we have both of those. And we're solving for a side length, so our little letters are going to go on top. Alright, so we have little a over sine of big A equals little b over sine of big B. Plug in. Out of room. So all I did was cross multiply. Now put all of that in your calculator. And what do you get? 14.7. 14.7. Alright, questions on that?
Maybe I'll use inverse and then finally like angle.
Right. Which is the same as what we did a long time ago, right? Back at the beginning of the semester. So by the time we get here, we're putting a bunch of stuff together that we've learned throughout the semester. Alright, questions on example 3. Alright, so do you see the difference? Okay, again, when are we checking for these special cases? When we have a what? Side-side angle. Okay, not to be confused with other things, remember? Okay, side-side angle. Alright, so, and then make sure that you have to check, because it's possible you could have no solution, one solution, two. Okay? Alright, let's look at this final example down here. Really no math to be done. They just want you to make sure that you understand and that you're thinking through this, okay? So it says, without using the law of sines, explain why A equals 104, little a is 26.8, and little b is 31.3 cannot be valid for triangle ABC. So without doing any mathematical work, okay, why do you think that this cannot be a triangle? We talked about this when we first started 7-1, I think, maybe, okay, but you may have forgotten. Okay, what do we know about our angles and our side lengths and how they correspond? Like, you know that little a goes with big A, you know that little b goes with big B, you know that little c goes with big C, right? But you also know that if it is the largest angle, then it's going to have the largest or the longest side, right? Does that make sense? Okay? But what they've said here is 104 is an obtuse angle, which means all three of my angles can only add to be 180, right? So you know that the other two that are left are not larger than 104, right? So that means that 104 has to be the largest angle in your triangle. But what do you see right here? It's shorter than little b, right? So is that possible? No. Okay? So that's what they want you to say. All right? So let's write this out in words. Because A is an obtuse angle, it is the largest angle, and so the longest side of the triangle must be little a. However, what? However, we are given B is greater than A. Okay? Now, you're not necessarily going to have a question on your test like this, okay? But it is making sure that you understand the concept, okay, of what we've talked about today, which goes with these ambiguous cases and helps you to understand why it's possible for you to have no solution, one solution, or two solutions, okay? All right, questions on this? All right, so we are moving into 7-3, okay? Now, hold your applause, but this is the last section that you're going to cover in this class, okay? Peyton gave me a praise God, okay? There may be some more in the room, okay? Or watching the video, all right? This is the last section that we're going to cover, so no more new material after this section. All right, so let's look at 7-3. All right, so we're doing more of the same, okay? But in 7.3, we're going to be talking about law of cosines. So we've been talking about law of sines. And with law of sines, you have to have a corresponding angle, measure, and side, right? Okay, and then at least one of the others to be able to find that missing piece, okay? So with law of cosines, you're not going to use it as much as law of sines, okay? But there are times where we don't have enough information to use our law of sines. So that's when we would use our law of cosines. But you're still using these laws and finding your missing pieces, okay? Based on what information is given to you. All right, so we're going to look at several cases of these. Here are your law of cosines right here, okay? Again, obviously, just like your area of a triangle, that's different, okay? Based on what information is given. These are also on your identity sheet, okay? So you've got those on your identity sheet. All right, and then it says that is, according to the law of cosines, the square of a side of a triangle is equal to the sum of the squares of the other two sides minus twice the product of those two sides and the cosine of the angle included between them. Blah, 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 right? Okay? It's just these three equations written in words, okay? That's all that is, all right? But again, you have them right here, and you have them on your identity sheet, okay? So we're gravy. All right. Everybody got that? All right, so let's look at our example 1. So remember, on our sheet in 7.1, we said there were 4 cases. Okay, so we've talked about the first case. In 7.2, we looked at case 2 where we could have no solution or 1 solution or 2 solutions, okay, our ambiguous case. So now in this section, we're going to look at our cases 3 and our cases 4, okay? So that's when you have to use your law of cosine. All right, so here we go. Example 1. You'll notice that it is side, angle, side. Okay, so we're given little b, we're given little a, and it says that angle ACB measures 132 degrees and 40 minutes. If they're giving us angle ACB, what angle are they giving us? C, because we know that whatever's in the middle, that's what angle they've given us, okay? So this is angle C, okay? Alright, so look at your formulas up at the top. And we have little b, we have little a, and we have big C. So which one of those could we use, and what could we solve for first? We can use the bottom one, right? And then we can solve for little c first, okay? So that's what we're going to do. We've got c squared equals a squared plus b squared minus 2ab cosine of big C. This is what we're using. Alright, so now plug in what you know. Little a is 423 squared plus little b is 259 squared minus 2 times 423 times 259 times cosine of 132 degrees and 40 minutes. Fun times, right? Okay, good news is I told you we use law of sines way more than we use law of cosines. Thank goodness, huh? Alright, so be careful and watch your parentheses, okay? You're just going to type all of that in as you see that, okay? Take your time and watch your parentheses. Alright, when I put this all in, this is what I'm getting. 394,510.5693. Are you getting that? Whoop whoop. Is that the final answer? No, that's what C squared equals. So now what are we going to do? Take the square root. Alright, now I'm going to show you right here on my calculator. Okay, I'm not going to retype all of that junk. I'm going to say second square root, second answer. And hit enter. Now, the side lengths that they gave us have how many significant digits? 3. So how many am I going to round this one to? 3. So what is it going to be? 628. Okay, has everybody got that from my calculator? We good? Alright, so then we have little c to be 628. Alright, so now we have little b that was given in the original, little a that was given in the original, big C that was given in the original, and little c. So now to find my other two angles, I can just use what? I can use my law of sines like I've been doing. You with me? Okay, so you only have to do this long, ugly one once, okay, and then you can go back and use your law of sines to find your other pieces, okay? So, it doesn't really matter, but I'm going to find angle A first. So again, if we're solving for angles, then where does that need to go? On the top. Alright, so here we go. Sine of big C over little c equals sine of big A over little a. I'm out of room, so I'm going to do it this way. Sine of 132 degrees, 40 minutes over 628 equals sine of big A over 423. Then what do? Cross multiply. Oh. And then what do you do with all that junk? Type it all in, and then you're going to have to do inverse answer, right? What are you getting? 29.688, blah, 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 blah. Yes. Okay. But your angle measure was originally given in degrees and minutes. So you can either take your what's after the decimal and multiply that times 60, or you can do second angle and go down to your DMS And that is telling you that it is 29 degrees and 41 minutes. Did y'all get that? It has some seconds, but we're rounding it to the nearest minute. Alright, then what are you going to do? The same thing to find big B, okay? Try that on your own. Find big B. I'm running out of room, so I'm just gonna do that. Y'all get 17 degrees and 39 minutes. Alright, so we did the exact same thing on that one that we did to find angle A. I just ran out of room, so I didn't write it all out. Sorry. Alright, so what questions do we have on example 1? Alright, let's look at example 2. Alright, so on example 2, they give me big A, they give me little b, and they give me little c. Okay, so based on that, what formula are we going to use? We're going to use the law of cosine, specifically which one? The a squared equals b squared plus c squared minus 2bc cosine of big A. Alright, so now plug in. We're doing the same thing we just did. So you have $12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times cosine of 42.3. Put all that in. Alright, I'm getting 109.6997733. Are you getting that? Okay, then what do? Take the square root of that. Again, you can do second square root, second answer. We're rounding to how many digits? 3. So we're getting, if you do that, 10.5. Right? Alright, now what? Law of sine. Okay, specifically, what are we going to need to use and find? We're going to use big A and little a, and we need to find big B and big C, right? So it really doesn't matter which one of those we find first, but we are solving for an angle measure, so we're going to put the angle measure on top. Alright, just for the sake of time, I feel like we've got law of sine at this point and cross multiplying and all that jazz. And that, you know, that in my math lab they may tell you how we're doing significant digits because that's what we've been doing, but remember, even when we did these sections before solving triangles, when they were right triangles, sometimes my math lab tells you to round. It tells you specifically what it wants you to round to. So if it wants you to round your little a to 2 places after the decimal, then make sure that's what you use when you go to find your next one, because those other answers will be based off of that. Does that make sense? Okay. Alright, so what are you getting here? 55.77588. Yes? Okay. So 3 significant digits would be 55.8. So what's the only other piece we're missing? Big C, right? Okay, now you can do law of sine again, or we also know what? That all 3 of them equal 180. Or you can say 180 minus 42.3 minus 55.8. And what do you get? Are you getting 81.9? It's possible that it might be a smidge difference, but it shouldn't be much. I mean, it should still round to be the same thing. 80.8? Shouldn't be off that much. Let's see. That would be... I'm not saying it's not possible. Trying to do this in my head and I forgot what I'm supposed to be doing. Totally do. Totally do.
So when you add those 3 over, it's 178.9.
Right. Well, and you got to remember, when you go and try to add these back up, we've rounded every single time. So you're probably, even with my answers, I mean, I haven't added those, but even with mine, it's probably not going to be like perfect. You know what I mean? Because you've rounded every single answer. And so every answer is an approximation. So it's going to be really, really close to 180, but it's not going to be exact. There's no way for it to be exact if you're chopping off every answer that we find. So keep that in mind as well. On my math lab, pay attention to what they want you to round to, and I think you'll be fine. On your test, remember that it's multiple choice, so it shouldn't be an issue because, you know, you're going to be choosing from that. Off the top of my head, I'm not sure if your test is, I'll have to look at that. I don't remember how many of your questions are multiple choice and how many are not.
Like when you enter these in, like if I put in 80.8 and the answer on my math lab is 81.9, would it still give me?
There usually is a margin in there. You know what I mean? Like there's usually a margin that it'll accept. Yeah. So that's usually why you're still fine on that. But if you'll send me a message, I'll double check because I don't remember off the top of my head how many of yours are multiple. They may all be multiple choice as well, but I don't remember for all mine because they're all taking pencil paper tests. So, all right, questions on that? All right, so let's look at example 3. Okay, so now we have switched and we're going to have a different case, right? Okay. Because we've at least been given one angle and two sides in these. Now what's going to happen in this case? No angles, and you have all three sides, right? So you're still going to use law of cosines, but you're going to have to use your law of cosine to solve for an angle measure. So how we work that is going to be different. Once you get through the first step of using law of cosines, then you're good because you can keep using law of sines, okay? So we're given little a, little b, and little c, okay? So really doesn't matter which angle we solve for first, okay? I'm going to solve for angle C, okay? Which means we're going to be using that last equation, right? Okay, but it really doesn't matter. But I do want you to pay attention to how we solve this because it is going to look different, okay? All right, so we're using this. C squared equals A squared plus B squared minus 2AB cosine of big C. Now, this is what we're solving for, is big C. Okay? So, pay attention. Alright, so we're going to plug in little c, and that's going to give us 21.1 squared. Little a is going to be 9.47 squared. Little b is going to be 15.9 squared minus 2 times 9.47 times 15.9 cosine of big C. So I'm going to give you a second to get all that written down. Alright, now you can do this, each individual piece, put it in your calculator one piece at a time, okay? But I just want us to talk through this because it's going to be a lot easier and you're going to have a lot less decimals to rewrite and move over and all that jazz if you do it all at one time, okay? So let's talk through how this is going to look. Alright, if I'm solving, my end goal is to find big C, right? So I know that eventually I'm going to get all my junk on one side except for sine of big C, and then what do I know I'm going to have to use to find big C? How am I going to have to put that in my calculator? Inverse, okay? So you already know that we're solving for an angle measure, so eventually you're going to be putting that in as inverse, okay? I also know that I need to get all of this junk to the other side, right? Okay? So, think through this with me without writing everything out, okay? If my end goal is to get this all by itself, then what would I do with this? I would subtract it. What would I do with this? Subtract. Then that would just leave this junk right here, right? All of that is what? Multiplied times each other. How would I get rid of all that junk? divide. Okay? So that's what I want you to do, and I want you to do it all at one time so you can put it in your calculator all at one time and make your life way easier. Yes? Alright, so this is what we're going to do. You know that you're going to enter this as cosine inverse, okay? So this is going to look like 21.1 squared minus 9.47 squared minus 15.9 squared all over negative 2 times 9.47 times 15.9, and that is going to give you big C. Okay, now what do you think is going to be the kicker on this? Parentheses. Okay, you need a big one it's gonna already open this one when you start. You need to put that in parentheses every time you square it, division, and put all of this junk in the bottom in parentheses, and then close that big parentheses. Does that make sense? Actually, I did not do it, but you probably need to put all that junk in the top in parentheses as well. Yeah, I didn't do it the first time either. Yeah. And if you want to do that, that's a good question. Peyton said if you forget to do your cosine inverse, if you want to do all this junk in the top, hit enter, divide it by all that junk, hit enter, then do cosine inverse second answer, you can totally do that. If you're, because the parentheses get a little yucky on this. Not gonna lie. I rounded to one place after the decimal, probably because that's what the book did or told us to do, because there's obviously not any significant digits here, but I missed a parenthesis somewhere. What are y'all getting? Okay. You're supposed to be getting 109.9. Okay. I don't know what I'm doing. I've obviously typed mine in wrong twice. So, this is what you're supposed to be getting, but I'm doing something funky. I don't know if I typed in my... I know my mode's right because we've been in it all day. Alright, so now once you know big C, then again you can do what you've been doing, right? Okay, is everybody with me on that? Alright, so now you can use your law of sine, right? So we can do sine of big C over little c equals sine of big B over little b. Alright, and when I find big B, I'm getting 45.1. Are you getting that? Alright, and now that we know 2 of our 3 angle measures, what can we do? We can subtract. I'm getting 25. Are y'all getting that? Sweet. Alright, questions on example 3. Alright, hear me out on this. Example 4 is doing the exact same thing, but they don't want you to solve the whole entire triangle. They just want you to solve for angle B, okay? So essentially, that's just what we did in this top part right here. And then you would stop, okay? But you would make sure that you plug it in to find angle B. So you would use that second formula. Does that make sense, okay? And then round to what they tell you to round to. And then down here, they've got your case 1, case 2, case 3, case 4. All that is recapping what we've already done and the steps that we've already went through, okay? But I feel like at this point in the ball game, my Monday, Wednesday class is watching this video going, will this video ever end, okay? So we are going to, we've covered everything. I have not left you hanging on anything. And so we have everything that we need for this next test. As a reminder, your study guide for both classes is already posted in Canvas as an announcement, okay? So that is there, okay? So everybody say bye to the Monday, Wednesday class. Bye, Monday, Wednesday. All right.